You have probably heard scientists quote p-values whenever they report the results from their experiments. But what exactly is a p-value anyway? In this video, I will clearly explain what a p-value is. A p-value is an abbreviation for probability value, and the p-value is a number that can be any value between 0 and 1. But what exactly does this number represent? The official definition of a p-value is quite challenging to understand. A p-value is a probability of obtaining the observed difference or a larger one in the outcome measure, given that no difference exists between treatments in the population. In other words, it is the probability of having a false positive result. So the best way to explain what is a p-value is to use an example. Let's say you want to perform an experiment to see if a new type of weight loss drug, drug X, causes people to lose weight. So you randomly sample a collection of volunteers and randomly assign them into two groups, Group A and Group B. You give Group A a placebo. In other words, this contains no active ingredients. Group A is therefore the control group. And you give Group B the new drug, drug X. The participants are weighed at the start of the study and at the end of the study, and this way you can work out the body weight difference. At the end of the study, you work out Group A's average body weight difference with 0 kilograms. In other words, they did not gain or lose any body weight. Group B's body weight difference was negative 1 kilogram, so on average they lost 1 kilogram of their body weight. So does this mean that the drug worked? To determine this, we first asked ourselves, what would happen in a world where the weight difference in volunteers who received drug X is the same as the weight difference who received the placebo? This is where the null hypothesis comes in. Usually, the null hypothesis states that there's no difference between groups, so our null hypothesis is that the weight difference in those who receive drug X is the same as the weight difference in those who receive the placebo. Now we can ask ourselves, if this null hypothesis was true, what is the chance of probability of discovering a 1 kilogram reduction or more in body weights in those treated with drug X from our sample? This probability or p-value measures the strength of evidence against the null hypothesis. As you can think of this as a court trial where the defendant is innocent until proven guilty. In this case, the defendant is a null hypothesis. The smaller the p-value, the stronger the evidence against the null hypothesis. To determine the p-value, scientists use what are known as statistical hypothesis tests. Common examples include the student t-test and a one-way ANOVA. Since this is a top-line overview, I will not bombard you with statistical jargon, but instead pretend we have performed a statistical test during our data. So after inputting our data into a statistical test, we get a p-value in return. Let's say, for example, the p-value is 0.02. It's worth mentioning that the p-value is a fraction. However, it may be easy to convert this into a percentage to simply understand the concept better. So a value of 0.02 would be 2%. I simply multiplied the fraction by 100. But what does this p-value represent of 2% actually represent? Essentially, this means that there is a 2% chance of having a false positive result, which is obviously low. To put that into perspective, a 2% chance is 1 of every 50 experiments. So how can this be? What is accounting for this 2%? Simply, this 2% can be accounted by a random noise. Let's elaborate a bit more on random noise. There are quite a few things that can impact a p-value, and some of these factors are collectively known as random noise or random chance. One type of factors that can contribute to random noise, especially in human studies, is the coincidence of random sampling. For example, humans can exhibit a large amount of variation between one another due to genetic and environmental influences. If we relate back to our example, some humans may contain an unknown gene that speeds up their metabolism and cause them to lose weight more than those without the gene. When recruiting volunteers for our experiment, we did not perform any DNA analysis before randomly assigning the volunteers to either Group A, the control group, or Group B, the drug X group. So there is no way of knowing who was a carrier of this gene or not. So imagine a situation where just by pure coincidence, more volunteers with the high metabolism gene are placed in Group B compared with Group A. So you can see that this scenario favors Group B. Ultimately, you can see that just by pure coincidence of random sampling, this can have a knock-on effect on the p-value. So to sum up, a p-value is a value between 0 and 1. This p-value represents the probability of obtaining a false positive result. And finally, random noise can affect the p-value. A common example of random noise is a coincidence of random sampling.